Hi everyone, Assalamualaikum. In this video, we are going to continue with last chapter in our syllabus, which is chapter 5, Applications of Definite Integrals. First, we look at area between curves. Okay. Let's say we are given this diagram. Okay. Area of the shaded region is given by integration from x equals to a to x equals to b, and then top minus bottom, right? And we use integration with respect to x, and we also use lower and upper limit on x-axis, alright? And for function top and bottom, we need to write in terms of variable x from here. And to write in terms of variable x means we need to write y as a subject, right? So area between curves equals to integration from x equals to a to x equals to b, top minus bottom dx. Alright, this is the first formula for area between curves. Alright. Alright, now we look at this diagram. Okay. Area for the shaded region equals to integration from y equals to c to y equals to d, and then right minus left, right? And when we use right minus left, we need to integrate with respect to y. And when we integrate with respect to y, we need to use limit on y-axis, right? And if we integrate with respect to y, right and left function must in terms of variable y, right? And to write in terms of variable y, we need to write x as a subject, right? From here. Okay. So, we have second formula for area of the shaded region here equals to integration from y equals to c to y equals to d, and then right function minus left function, right? And for both formula number 1 with respect to x and formula number 2 with respect to y, area always positive, right? Alright, now we look at example 1 from the previous semester papers. Figure below shows the region R bounded by the curve x equals to y squared plus 1 here, and the line x equals to 7 minus y, okay, here. Find the coordinate of M and N here. And then number 2, find the area of the shaded region R, means area of this. Okay. Alright, first we look at number 1. Find the coordinate of M and N. M and N here are the intersection point. Okay. So to find the coordinate of intersection point, we need to solve simultaneous equation. Okay. Between equation x equals to 7 minus y, we naming it as equation 1, and x equals to y squared plus 1, we naming it as equation 2. Okay, then we can substitute equation 2 into equation 1. Okay, so we get this. Okay, from x equals to y squared plus 1, we substitute into x here. So we get this. Okay. So we get y squared plus 1 equals to 7 minus y. Okay. This is quadratic equation. So to solve quadratic equation, we must write right hand side equals to 0. Means that we bring all the term to left hand side. So we get y squared plus y minus 6 after we simplify. Okay. And equals to 0. Alright. Then we can factorize. So we get y minus 2 times y plus 3 equals to 0. When we equate each factor to 0, so we get y equals to 2 and y equals to negative 3. Coordinate here means we need to write in terms of bracket x and y. Now we find the values of y. So after that, we need to find the values of x. Okay. So to find the values of x, we substitute the first value of y equals to 2. We substitute either into equation 1 or equation 2. Let's say we substitute into equation 1. So we get x equals to 7 minus y. Y we replace by 2 here. So we get x equals to 5. Okay. And then for y equals to negative 3, we substitute into equation 1 here. So we get x equals to 7 minus y equals to negative 3. Then when we simplify, we get x equals to 10. Okay. Alright. So now we need to write coordinate m and n. Okay. Alright. Since m on the left side, okay. So to be logic, our x for m should be 5. Okay. And our n on the right side should be 10. Okay. And when x equals to 5, y equals to 2. When x equals to 10, x equals to negative 3. Okay. When we write coordinate, we must write x first, the value of x first, then the value of y. Alright. So this is coordinate of m and n. Alright. Alright, now we continue with question number 2. Find the area of the shaded region R. Alright. To find the area of the shaded region, we have two formulas. The first formula, we integrate with respect to x. We use top minus bottom and we use limit on x-axis. And if we use second formula, we need to integrate with respect to y. And we use right minus left. And we use limit on y-axis. Okay. So now we can check which formulas is suitable. Okay. So let's say we check with the first formula. Okay. Means we integrate with respect to x. So we need to check the values on x-axis. Okay. So from here, okay. Now let's say we try with formula number 1. So from here, let's say from coordinate of m and n, or coordinate of intersection point here, okay, we draw to the x-axis here, but the line is cross the shaded region. Okay, so the first formula is not suitable because the coordinate of intersection point here, the end point here, is cross the shaded region. Okay. Then we can try with formula number 2. Okay. Right. For formula number 2 here, if we check limit on y-axis for the end point here, okay, here, so the line not cross the shaded region, means that formula number 2 is suitable. Alright, so we use formula number 2, means we integrate with respect to y, and then we use right minus left, and we use limit on y-axis. Alright. So from area equals to integration from C to D. Okay, C here means lower limit. Okay. So y equals to negative 3 and d means upper limit. So y equals to 2 and then right function minus left function and we integrate with respect to y. Okay. Alright, since we use limit on y-axis, okay, so we need to use right function minus left function. Okay. And then when we use integration with respect to y, we need to write in terms of variable y. Okay. And to write in terms of variable y, we need to write x as a subject. Then we get x equals to and then the function in terms of variable y. Okay. Alright. And then from here, okay, this is lower and upper limit. And we use lower and upper limit on y-axis. Okay, if we use integration with respect to x, we must use limit on. If we use integration with respect to y, we need to use lower and upper limit on y-axis and we need to write the function in terms of variable y. And to write in terms of variable y, we need to write x as a subject. Alright? Got it? Alright, and then after that, we get area equals to integration from negative 3 to 2 and then we replace the right function, okay, equals to 7 minus y. And then in between is minus, okay. And then left function, we replace by y squared plus 1. Alright? Alright, so from here, we get all in terms of variable y. And we use limit on y-axis. Remember, when we integrate with respect to y, we must write all in terms of variable y. And we must use limit on y-axis. Alright? And after that, we can expand and simplify. So we get area equals to integration from negative 3 to 2. And then after we expand and simplify, we get 6 minus y squared. Okay? So from here, we can integrate with respect to y. Right? And no more integration sign after we integrate. Okay, so we get area equals to, when we integrate 6 with respect to y, we get 6y. Minus, when we integrate y with respect to y, we get y squared minus 2 over 2. And then minus, when we integrate y squared with respect to y, so we get y cubed over 3. This is definite integral. So no need to put plus c, but we need to write square bracket with lower limit and upper limit. Alright? Alright, after that, we replace upper limit into variable y. Okay? And then in between must minus sign. Okay? After that, we replace lower limit into variable y. Okay? Then we simplify. So we get area equals to 125 over 6. And then we must put units squared for area. Okay, so this is the final answer. Area of the shaded region here equals to 125 over 6 units squared. Okay, and area always positive. Alright. If we get area negative, maybe there is something wrong in our calculation or our integration. Okay? Alright? Coming up next, more examples for area between curves. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.